This is basically going to take you to the concepts and some examples of what you need to know for the 2.1 and 2.3 test. When I get to the problems that use a graphing calculator, I will let you know that those are the ones that are going to use the graphing calculator. You're going to do it in the same order you did last time, where you come and you get the graphing calculator part first, then you'll put your graphing calculator on the floor, and you'll get your non-graphing calculator part second, okay? And again, you want to watch your time. Some of you got stuck on that first part last time and then had to rush at the end. You don't want to do that, okay? So we start with non-graphing calculator part, okay, which is 2.1. We start the review with 2.1, putting it into standard form. So this is your complete the square. I want you to change this, okay, to an 11, because I'm telling you right now it's not going to be nice even numbers, okay? So on the right-hand side is kind of the steps for for completing the square. You're going to start by grouping ax squared and b. And then from there, if the a is not 1, which it will most likely not be, you're going to have to take it out. So I take out a -3, which means I take it from here and from here. So some of you in your quiz video forgot to take it from the second term. This would be a -11/3x. I'm going to leave the space. I'm going to fill that in, and I'm going to bump the +1 to the end. Some of you took the first term off the 1 at the end, or whatever that c was. You don't do that. We've separated it out for that reason. All right, so now I've got to find what my middle term should be, which means I take the b, which is 11/3. I divide it by 2, which is the same thing as multiplying by 1/2, and I get 11/6. And then I square it, and I get 121/36. That's what I add inside my parentheses and subtract from outside the parentheses. With me so far? Before I do that, I have to account for that -3. So I multiply -3 times -121/36. Some of you like to make your life miserable, and you multiply it out the top of that, making it like something like -363/36. My advice is reduce if you can. So 3 goes into 36 12 times. Negative times a negative means this is going to be a positive 121/12. So I'm here, -3x squared minus 11/3x plus 121/36 plus 1 plus 121/12. To combine the 1 and the 121/12, I have to give them a like denominator, which should be 12/12. And now I've got -3x squared minus 11/3x plus 121/36 plus 133/12. Now my whole goal with complete the square was to make what's inside the parentheses a perfect square trinomial so I can factor it to get that into standard form. To do that, I would leave the -3 in the front. I would square root the first term inside the parentheses, which is going to be x. Square root the last term, which is 11/6. Take the sign from the middle, which is a negative, put it in parentheses and square it. And then the 133/12 is still at the end. So f of x would be my function equals -3x minus 11/6 squared plus 133/12. Get over the fact that they're not pretty numbers. You're not going to get all whole numbers. Okay? Fractions are your friends. Get used to them. So you will get a question exactly like that forces you to use complete the square. Okay? There are 2 questions with quadratic. One where it says complete the square and one where it says to solve it, and you can choose which method you use, okay? So let's say, and I'll show you an example real fast of the second method, but let's say I solve this, put it in standard form, and then I have to answer all the questions based on it. So that's what's at the bottom there. The vertex of this function would be hk, which is the opposite of what goes inside the parentheses, or 11/6. And then the k would be what's outside the parentheses, 133 over 12. Obviously, if I'm going to graph those, I have to convert them into mixed numbers. The axis of symmetry is x equals h, whatever the x coordinate of your vertex is. That x equals is an important part of that answer. If you don't have x equals, if you just write 11, 6, you are going to lose points. The axis is a line, and the only way you get a line is if you do that x equals. I'm about to tell you the answer to one of the questions on your test. Are you listening? The domain of a parabola is all real numbers are negative infinity to positive infinity. Feel free to share that with your friends. Okay? The domain, so if you are going to get one question right on this test, it better be that. Domain is all real numbers, negative infinity to positive infinity. Okay? There's no restriction on domain for a quadratic. The range, if my graph is going to open up, is going to be the k value of my vertex to positive infinity. If it opens down, is negative infinity to the k coordinate of my vertex, or the y coordinate of my vertex. And the number gets the bracket, and the infinity gets the parentheses. So if I'm talking about this example, is my graph going to open up or down? Down, because that negative 3 is on the front, right? Which means the range would be from negative infinity up until the k, which is 133 over 12. And the domain is all real numbers. To find the intercept, so to find the the y-intercept, I'm going to plug 0 in for x. To find the x-intercept, I'm going to plug 0 in for y. Christian. So the question at the beginning says complete the square. It says put it in standard form, but there's no graphing questions based on that. You're literally just completing the square. Question 2 is going to give it to you in quadratic form, and then is your choice on which method you use. So I'm showing you how to answer it based on complete the square, and then in a moment I'm going to show you how to answer it based on the other. Okay. So this example is not great for the x-intercept because I changed it, so now it's not factorable anymore. Okay, but if it was factorable for the x-intercept, I would set it equal to 0, factor it. If it's like this, where it's not factorable, then you'll use the quadratic formula, which I'll, at the end of the video, refresh your memory on.
When we find the x-intercept, is it going to be a perfect square or no?
Well, the you mean if it's, yeah, no, x-intercept, if you do it from here, right? So if I do it from here.
I mean the y-intercept.
The y-intercept, you just plug 0 in x. The easiest way to do that is to go from the beginning and make it 0, 0, and then it would be 1. So the y-intercept, the easiest thing to do is to just go from my initial equation. The x-intercept, you're either going to take this function, like the teal one, subtract the negative 33 over 12, divide both sides by negative 3, and then use the even root property. Or you could use the quadratic from your initial one, or, best case scenario, it's factorable, and you could do that one, okay? And then max and min. So if my parabola opens up, there is a minimum, and it is the k value. If it opens down, there's a maximum, and it is the k value, or the y coordinate of your vertex. So in this case, we said our parabola was going to open down because it's a negative 3. So in this case, there would be a max, and the max would be at 133 over 12. All right, so now I'm going to show you the other way. So let's say I get given a new equation, which you will. You'll get given a new equation, and it just says find the vertex, find the intercept, find the domain, find the range, all that stuff, and graph it. And you have the option of forcing this in to complete the square, which I won't do again, but you can do it again if you wanted to, or using the other method. To find the vertex using the other method, you do negative b over 2a to get your h. So in this case, I'd get negative 5 over 2 times negative 3, which is a negative 5 over negative 6, or positive 5, 6. And that's the x coordinate of my vertex. And then I take that and plug it in. I'm going to take it and plug it back in to get the k. So negative 5/6 squared plus 5 times 5/6 plus 2. And I get negative 3, 25 over 36 plus 25 over 6 plus 2. This reduces negative 25 over 12 plus 25 over 6 plus 2. I need them all to have the same denominator. So this becomes negative 25 over 12 multiplied by 2 plus 50 over 12 multiplied by 12 plus 24 over 12. And then negative 25 plus 50 is 25. 25 plus 24 is 49 over 12. Yep. Where you cannot to graph? No, you can use it. If it says put it in standard form, which question number 1 is going to say, put it in standard form, then you've got to use complete the square. But you don't have to graph that one. Okay, so there's my vertex. So you choose what you're better at. If you're great at complete the square, do complete the square. If you're not so great at complete the square, switch it to negative b over 2a. Don't get 2 questions wrong. And then actually, you'd get a lot more than 2 questions wrong because this question then leads into x-intercept, y-intercept. So if you get the equation wrong, okay, you can continue to get the rest of it wrong. So x-intercept, I'm going to take my equation. I'm going to set it equal to 0. So 0 equals negative 3x squared. Oh my goodness. Squared plus 5x plus 2. Okay, ideally it's factorable. So let's start there. Negative 3x and x. Factors of 2 would be 2 and 1. This is 1. This is 2. Outer and inner, that's 6x minus 1x, which is 5x. If it was not factorable, then I would use the quadratic formula, which again, I'll review at the end of the video when we get to it with the zeros. So now that it's factored, I set these each equal to 0. I'd get negative 3x equals 1, and x equals negative 1/3, and x equals 2. Those are my x-intercepts. And then the y-intercept is super easy to do when it's in standard form. Okay, if this is, or in quadratic form, if this is 0 and this is 0, then the y-intercept is just the number that's by itself. So it'd be 0, 2. Karina. I took the equation I was given and set it equal to 0 and then factored it. This over here. So when you factored. So what did you get? Okay. Because that's the only combination. You can take out a negative, like you can multiply everything by negative 1 because it's set equal to 0 if that first digit confuses you, but you still get the same answer. So if you do that, then this is a positive 3x and an x. Factors of negative 2 that sum to negative, or that when multiplied out would sum to that negative 5 would be negative 2 and positive 1. You'd still get a negative 3/2 and a positive 2. So the other way to factor, if you have a negative, like if you have a number on the front and you're struggling with trial and error, then the other way to factor is to multiply the first and the last terms together. So negative 3 times 2 gives me negative 6. Find the factors of that sum to the middle term. So 2 numbers that multiply together to give you negative 6 but add up to positive 5 would be what? -6, +5. So -6 means one sign's different. Yeah? Well, but it's got to be a +5. So it'd be +6 and -1, right? And then you replace your middle term with those two terms. So +6x and -1x plus 2. And then you can group these and factor by grouping. So take out a -3x, and I'd get x minus 2. Take out a -1, and I'd get x minus 2. So if you're not as great with trial and error, or there's a lot of possibilities, like if your first term is 12, I don't want to be messing with the factors of 12, being 1 and 12 and 2 and 6 and 3 and 4. So you can always do it that way. It's faster. I typically, if the front and the back are prime, I stick to trial and error. But if they're not prime, I'll use that second method. Great question. So when you're giving me the answers for x and y intercepts, I want them in coordinate form. So your x-intercepts are going to be -3, 0, and 2, 0, and your y-intercept is 0, 2. And then I would use all that information to graph my parabola. Okay, so I would plot my vertex, I would plot my intercepts. For this, it's going to be enough information to graph. If it wasn't, you can plot some additional points. So I've got -1/2, -1/3, 0, 2, 0, and 0, 2. And then my vertex, which was 5, 6, and 49/12, which is 4 1/8. So 5, 6, and 2, 3, 4 1/8. And then again, you're going to ask domain and range and max or min. So you should be able to answer all those questions based on the graph. Yep. All right, also from 2-1 is finding the equation given the vertex and the point. So this was also on your quiz, okay? Hopefully this is the easy one. The vertex is your h and your k, the point is your x and your y, and you're plugging it into y equals a times x minus h squared plus k. So the y is 5, the a is our unknown, the x is 2, the h is 3, and the k is a -4. And then I want to solve for a. So I get 9 equals a times 1, and a is 9. And then I take and plug back in just the a, the h, and the k. So I get y equals a, which is 9, x minus h plus k. And you can either write it as y or f of x because it is a function, so it's totally up to you. I'll take either answer. Just make sure you give me a full equation. Okay, make sure the y and the f of x are there. Okay, so also from this section, and this is the part with the graph and calculator, is the word problem. Okay, which was kind of like the one that was on your quiz. Okay, it's going to give you, so we did one in the notes, we did one in the homework, and you did them on the quiz. It's going to give you something that's a quadratic, some sort of word problem situation in which an object goes up and comes back down, or goes down and comes back up, something like that, where you'll have to graph your function using your graphing calculator. And then answer questions based on your function. So let's say my function looks something like this. Okay, it could ask me, what is the maximum height? So maximum height, I'm going to trace, go to the maximum, and the maximum height, or it could be minimum if it's open the other way, would be my k value, or the y coordinate of your vertex. If it asks, when does that max happen, or min happen? Now I'm looking for the x coordinate of my max. So this would be the h, or the x coordinate of my max. So where does it happen, or sorry, what is the max is going to be the k. When does it happen is the x.
How do you know find the difference?
What do you mean? You just got to pay attention to the question that asks. So your question might say, what is the max? So you're looking for the x. And then Christian's question could say, at what point does the max occur? When does the max occur? And then that's going to be your x coordinate. So you just got to read your questions. It could ask you, so the punt example that we had in the notes said, at what height is the ball when his foot hits when he kicks it, right? And so then that would be like the y-intercept. So you could be looking for the y-intercept, at what height is the ball hit, or at what height is it thrown, or something like that. And then you could, so that's the y-intercept. And then you could also get a question like, when does it hit the ground again? When does it come back and intersect with the ground? Okay, and that would be the other 0 for your function. Again, using the trace feature, left bound, right bound, establish where that 0 is at. Taylor?
So if it was to ask when does it hit again, then that would be our x again?
Yep, that would be the x-intercept.
And also, if it said like horizontal, because like the one on the quiz,
Everybody's taking it, yeah.
but the one on the quiz,
And they would get a
said,
different one
it was
anyways.
going like horizontal.
Yep.
So that would be your x then.
Correct.
Okay.
So what's the horizontal distance, was the question?
Yeah.
Yeah, because
So if
they're
it's
all
vertical, then
different.
it'd be the y.
So if it said, what's the height? It's not really saying, it won't ask like what the y is when it hits the ground, because it should be 0. Like they won't ask something like that. You'll have to read it from, I mean, I guess it could, but it would be 0. Right.
So when it asks for the max height or the max, the minimum, would it be from the vertex?
Yes.
You'd be using from the vertex.
Yeah, but when you're graphing calculator, you'll go max or min.
Right.
Yeah, because there's no vertex on the graphing calculator. Okay, so that's going to be like your first question on the graphing calculator. Okay, word problem in which you're answering questions based on it. Okay. All right, in 2.2, you did the polynomials of higher degree. So this is where you're finding end behavior, your zeros, your multiplicity, your intercepts, and your graphing. So this is not involving your graphing calculator, okay? So end behavior, remember you're looking for the highest exponent. You always want to put it in order from highest to lowest. And then identify what's the exponent. So if I have an even exponent and the coefficient is positive, then they're going to both point up just like a parabola. If it's an even exponent and it's negative, then they're going to both point down. And then the other situation is if it's an odd exponent and it's positive, okay, it's going to rise right and fall left. And then if it's odd and negative, now it rises left and falls right. So this is chunked together just like your quadratic. You're going to get given one equation, and then it's going to ask you a series of questions based on that equation. It's going to ask you for the end behavior. It's going to ask you for the zeros. So for that, I'm going to set f of x equal to 0. And then solve it. So factor and solve. It's going to ask for the multiplicity, which is the number of times a root occurs. If it's even, it's going to bounce. If it's odd, it's going to cross through. And then you'll graph it. Most likely, you're going to have to plug in some extra points in between your zeros to find where it crosses, okay? How high it goes, how low it goes. Okay, so now I'm going to work through the example that's on the bottom. So it says f of x equals negative 4x to the 4th, or sorry, negative 2x to the 4th plus x to the 6th minus 3x squared. So I want to figure out the end behavior, and to do that I got to put this in decreasing degree order. So x to the 6th minus 2x to the 4th minus 3x squared. The highest exponent was even, and the coefficient on it is positive, so both of these arrows are going to be pointing up. To find the zeros, I'm going to set this equal to 0 and factor, so I can take out an x squared, and I get x to the 4th minus 2x to the 2nd minus 3. So when it's x to the 4th and x squared here, I'm going to factor it like I would in normal trinomial, except that instead of it being x, it's going to be x squared. And then factors of negative 3, that sum to negative 2 would be negative 3 and positive 1. And then solve this, so x squared would equal 0, x squared minus 3 would equal 0, and x squared plus 1 would equal 0. So this is plus and minus the square root of 0, which is 0 with a multiplicity of 2, so that tells me it's going to bounce there. This would be x squared equals 3, x equals plus and minus the square root of 3, so I get negative square root 3 multiplicity of 1, and the square root 3 multiplicity of 1. And then the last one, x squared equals negative 1. When I go to square root that, I get plus and minus the square root of a negative number. So that's not a real root. So when I list my zeros, it would simply be 0 with a multiplicity of 2, negative root 3, and positive root 3. The y-intercept would come by plugging in x as 0. So if this is 0 and this is 0 and this is 0, then my y-intercept is 0, 0. And then I put that all together to graph. So I pulled a graph in here. I'm going to start with my zeros, so negative root 3, which is a little bit bigger than root 1, but smaller than root 4, probably closer to root 4, which would be closer to 2, so like negative 1.8 maybe. And approximate 1 there, and then a 0 at the 0. Both arrows are pointing up. It's going to cross through here, bounce off here, cross through here, and go back up. Now because all these exponents are even, if I plug in a negative x to test for the y-axis symmetry, it would be symmetric to the y-axis, which means I just need to plug in 1 point, either the positive 1 or the negative 1, to see how far down to go on those loops. So let's say I plug in positive 1, negative 2, 1 to the 4th, plus 1 to the 6th, minus 3, 1 squared. I get negative 2 plus 1 minus 3, or negative 1 plus minus 3, which is negative 4. So now I know how far down to go on these loops, which would be negative 4. So I go down, I'm going to come back up, go down, and come back up. And that's what the graph should look like. All right, long division is 2, 3. So now we're starting 2, 3. So there's no graphing calculator portion from 2, 2. So long division, I'm going to start by making sure these are all in order from highest down to none and nothing's missing. Don't need to plug anything in. They are in decreasing degree order and nothing is missing. Divide by, do the same thing here. Make sure they're in decreasing degree order, which they are, and nothing is missing, which it's not. If it was, I would plug in a 0 as the placeholder for that point. So then I'm looking first to first. What do I have to multiply x squared by to get to x to 2x to the third? And it would be 2x. Multiply that times all 3. 2x to the third plus 4x minus 2x, sorry, 4x squared minus 2x, and then change your signs. This cancels. I get 3x squared plus 6x. Bring down my next term, which is negative 3. First and first again. So what do I have to multiply x squared by to get to 3x squared, which is a positive 3? Multiply that times all 3 terms. 3x squared plus 6x minus 3. Change my signs. These cancel, and these cancel. So the remainder is 0. So my quotient here is just 2x plus 3. If there was a remainder other than 0, I would put it over x squared plus 2x minus 1. So I'd get 2x plus 3 plus the remainder over the divisor. The next question says, use the remainder theorem and synthetic division to find the value of the function. So if I'm finding f of negative 2, I could plug it in, but these instructions tell me to use the remainder theorem and synthetic division, which tells you you're putting the negative 2 on the outside, and then you're doing synthetic division. I've got a 3 for the x to the third, 1 to the x to the second. I'm missing my x to the first, and then negative 4. Bring down the 3, multiply it, put it in the next column, and add it. Multiply it, put it in the next column, and add it. Multiply it, put it in the next column, and add it. And the remainder is my answer. So f of negative 2 equals negative 24. Okay, now we're using the graphing calculator for something like this one. It says find the possible roots, then use the graphing calculator to find one root and find the remaining roots by factoring or using the quadratic formula. So I'm going to look at my first, which is 1, and my last, which is 18, plus and minus the factors of the last over the first. So this is 1, 2, 3, 6, 9, and 18. All of it goes over 1. If there was a term like 2 there, then all of these would go over 1, and then all of them would go over 2. So these are my possible roots. Now I'm going to use my graphing calculator to find the graph. So I've pulled in this graph, and I said it in class, but I want to reiterate that on your test, I purposely pick functions that you won't see whole numbers that match your possible roots. You need to find one that matches your possible roots. It could be a fraction, okay, but it has to be in your possible roots. In this case, I see I've got a point right here at -3. So these, while they're obvious on this graph, will not be so on your test. So I would say -3 is one of my roots, put -3 on the outside, and then do synthetic division with 1, -2, -9, and 18. Bring down the 1. And I get 0. Had I not got 0, I would have known I did something wrong with my graph. But this is here. I'll get to this function, which is actually factorable, -3 and -2, and solve it. If it was not factorable, I would use the quadratic or the even root property to find the zeros. So the question says find the remaining zeros. Or if it says remaining zeros, I only need these two. If it says find all the zeros, then I need -3, 2, and 3. All right, then we have Descartes' rule. So remember, Descartes' rule would be based on, or finding the number of positive and negative rational roots. So when you, or real roots, when you actually go through this and you count your sign changes off the original, you'll see it goes from positive to negative, so that's one sign change. And then it goes to positive, that's a second sign change. And then it goes to negative, that's a third sign change. And then it goes to positive, that's a fourth sign change. So when you do the positive roots, it would be 4 or any other multiple of 2 below that, right? So I'm going to subtract 2 from that, which means it's 4 or 2 or 0. And the reason we do that is to account for the possibility of imaginary roots. For negative roots, the first thing you're going to do is plug in a negative x. In place of all the x's, and then simplify. So negative x to the fourth becomes a positive x to the fourth. Negative x to the third is negative x to the third times a negative, which means positive 3x to the third. Negative x to the second squared is a positive x squared. Minus a negative becomes a plus x, and then plus 1. Count your sign changes this time, and it's positive, 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 which means there are 0 sign changes or 0 negative roots. So you'll see a question just like this where you're asked explicitly this, but you can also use Descartes' rule with something like this question where you would count your number of sign changes. So if I just use it for positive, this is 1, stays negative, that's 2. So that would be either 2 or 0 positive roots. And then if you look at your actual roots, you'll see that there are 2 of them. So if I had gotten 3 positive roots when I was solving this, I would have known something's wrong based on the Descartes rule. All right, so this last example, I'm just going to review the quadratic formula. And I'm actually going to change this so that it's a negative because we haven't dealt with i's yet. So 3x squared minus 2x minus 4. And the quadratic formula would be done anytime you can't factor. So if I multiply the first and last here, I get -12. There's no factors of -12 that sum to -2. So I know I'm going to use the quadratic equation, which is -b plus and minus the square root of b squared minus 4ac over 2a. So a is 3, b is -2, and c is -4. So the opposite of -2 for b is 2 plus and minus the square root of negative 2 squared minus 4 times a, which is 3, times c, which is negative 4, all over 2 times a, which is 3. So I get 2 plus or minus the square root of 4. This is negative 12 times negative 4, which is positive 48, over 6. 2 plus or minus the square root of 52 over 6. 52 is 2 and 26, which is 2 and 13. So that breaks down into 2 plus and minus 2 root 13 over 6. And then they're all divisible, so all the numbers on the outside of the root, if they're divisible by the same number, which in this case they are divisible of 2, I would break that down. So it's 1 plus or minus the square root of 13 over 3. So if I'm just listing roots, then that's my answer. Like if I'm listing the zeros, that would be my answer. But if I'm using this to graph, I have to approximate what this would be like. So because root 13 is approximate, it's in between root 9 and root 16, so it's in between 3 and 4. So let's say we approximate it to be 3.6. This is a little bit closer to root 16 than it is to root 9. And then I would split this up so that it's 1 plus 3.6 over 3 and 1 minus 3.6 over 3. So this would be like 4.6 over 3, which is 1.5. And then this, which would be negative 2.6 divided by 3, or negative 0.8, no, 86, or so 87 if I was going to round it. So if I were to use these as roots on a graph, like let's say I was graphing this quadratic, then I would know to approximate my intercepts at 1.5 and then negative 0.8, something like that. So anytime you've got a quadratic that you can't factor, or even if you can factor it, you can use the quadratic to find the answers. And then just make sure that if it's a root, it's simplified, and that if you're graphing it, that you estimate those roots. All right, don't forget your graphing calculators tomorrow, and good luck.